have I ask because I have Postgres and I use Mac and I can't really access Microsoft.
Yeah, like I said, it really doesn't matter what you have. SQL is quite portable. So it doesn't matter. It would work on any of the management, database management platforms that you have, regardless of whether you have Postgres or DB2, it would work. Well, or MySQL, it would work. So it doesn't really matter.
All right.
Though I haven't used Postgres, so I can't say much, but I know that SQL is quite portable, so it shouldn't matter at all. The most important thing is for you to get the way SQL works. The language is a language.
Yeah.
So once you are it's like every other language. Once you can speak French, you can speak French in any country to any number of people who understand French. So it wouldn't matter where you speak it, so long as you are speaking it within a French-speaking community, they would understand you. If you get what I mean.
Yes, I do.
Yes. So is the same thing. Besides, SQL is quite portable, so it works across most of the database management platforms. As a matter of fact, it is presently the most used, I can even say the only used language for database management. There was one previously, NDL, but that has become obsolete now because it is no longer in use. Nobody uses that one now. So SQL is actually the de facto database management language. Right. So does that answer your question?
Yes, it does. Thank you.
Right. Okay. So welcome to Foundations of SQL, the fundamentals, sorry, of SQL. So I'm going to start slowly. We're going to start slowly with the understanding that there may be people here who haven't done SQL before. There may be people here who are quite advanced. I don't know. But if you have an idea of SQL, if you've been using SQL, can you kindly show by hand? I'm not, because I'm sharing screen, I can't see. But anyone not sharing screen, can you help me count? If you have been using SQL, can you kindly show by hand? Let's see. Is there anyone there who can help me count the hands? I can't see the hands because I'm sharing screen.
There's no hand at the moment.
There is no hand.
We have one.
Okay.
We have one.
Yeah, so that is Fiyi Foluwa. Fiyi Foluwa. So Fiyi Foluwa, how would you rate your knowledge in SQL? From between 1 and 10, where one is not so good, 5 is average, 10 exceptionally good. If you can unmute and talk. We are waiting for you.
He's talking, but it's really faint.
He's talking, but it's really faint. He's saying something.
Did anyone hear what he said? Is that a male or female name?
He's asking if we could hear him.
No, we can't hear you, Fee. Are you sure you are unmuted? All right, no problem. Let's. So the majority are quite new to SQL, right? So it is written SQL as I'm pronouncing it, but it can be pronounced SQL. or SQL. Some people want to pronounce it fully, especially where we come from. We want to pronounce every single letter of the word. So someone will say SQL. So yeah, whichever way you pronounce it, it's okay. But I would normally pronounce it SQL or SQL. So yeah, it's the same thing. Right. So like I was just saying, we are just starting from the basics. So we would go through it gradually and build speed as we get along. So ideally, a database language should allow a user to create a database and relation structures. Let me just start writing a few things down here so that I can send you the notes. I don't have any prepared slides because when I teach SQL, it's quite interactive. So I don't come with any prepared slides. The beginning is a bit of, it's more talk than writing or than practice. But as we get along, we would do some practice work. But I'll try to type a few things so that I can post these notes to you once we are done. Right, so like I said, ideally a database language should allow a user to create a database and relation structures. It should be able to perform basic data management tasks. And it's not strange that this class has been restricted to only those doing data analysis. Previously, it was open to all. So yes, I think there's a realization that it would serve data analysts better. But everyone actually with a knowledge of SQL is in good standing. So it's good for everyone to actually know a little bit of SQL. Right, so it helps, it should be able to perform basic data management tasks. So what are some of these data management tasks? It should be able to help data managers to insert data, to modify data, delete data if it is no longer needed, and also to perform a variety of simple and complex queries on the database. Now, SQL simply is a kind of, because of that, SQL is a kind of transform-oriented language. Transform-oriented language. Sorry, my typing is a bit slow, but yeah. It's a form of transform-oriented language. And what this means is that it is designed to use relations to transform inputs into required outputs. It transforms inputs into required outputs. So basically, that is what SQL is. There are two main versions or two main components of SQL. Two main components. Two main components. One, we have what we call data definition language. Data definition language. And we have data manipulation language. So this is DDL. And this is DML. So these are the two main components of SQL. Now, what is data definition language? Like the name implies, it defines what data your language is made up of. Now, we are at this beginning stage, we are not going to dwell on data definition language. We would start with data manipulation language and then build into data definition language. Simply because there are a few things that we need to know about data manipulation before we go into data definition. Now, what are some of these things that form data definition languages? They are things that we use to create the database. So things like the keyword create. Let me use caps. Create, alter, truncate, and drop. These are the components of data definition language. These four. And for data manipulation language, we have select, insert, update, delete. So as the name implies, the names imply, you can guess what these things would do. So for example, the word create would create a database. The word alter would make a change to the database. The word drop would, as the word implies, will drop the database or will drop a table or would drop some kind of data, right? Now, the word select would take certain required elements of or from the database. The word insert would input certain things into the database, and update would also do the same, whilst delete would get rid of certain pieces of data in the database. So these are the main parts, the key words or the key parts of SQL. Right. SQL is made up of a number of words. We will call them as reserved words, made up of reserved words and user-defined words. SQL made up of reserved words and user-defined words. So the reserved words are a fixed part of the SQL language. They have a fixed meaning. For example, the word select, the word insert. These are fixed parts of the language. Now, they must be spelled exactly as they are written, as required. So these are certain constraints on when you are using SQL. reserved words must be spelled exactly as required. They cannot be split across lines. Cannot be split across lines. I don't know if anybody knows what that means. Sometimes when we are writing in English and the word is, we get to the end of the page and we haven't finished, we put a hyphen and then continue on the next line. In Sql, we can't do that. So user-defined words, on the other hand, are made up of words conjured by the user themselves. So they can be anything, but the reserved words are a fixed part of the SQL language, right? But user-defined words are not. We can use any word at all that we want as a user-defined word. So with user-defined words, the spelling really doesn't matter. So long as you use a word that has been used correctly in a database, it wouldn't matter at all what you use. But with the reserved words, they must be spelled in exactly the same way as are required. Now, most statements in SQL are case insensitive. Most SQL statements are case insensitive. Case insensitive. And what that means is that they can be typed as either uppercase or lowercase. It doesn't matter. So the key words here, the reserved words here, for example, that I've typed in caps, can also be typed as lowercase letters. In lowercase letters, it wouldn't matter at all. However, for the sake of readability and to enable the reader to differentiate between the reserved words and user-defined words, normally, in most cases, you would see that these reserved words are written in uppercase. But it wouldn't matter at all if they were to be written in lowercase. Is that making sense? It wouldn't matter at all. Right. Also, SQL is free format. Free format. Now, what this means is that it doesn't matter where certain words appear in the statement. We will see examples of that. It's a bit difficult to explain this particular part, but we will see examples of that as we go on. Right. Now, a few precautions though. Each clause in the statement should begin on a new line. Each clause in a statement should begin on a new line. Now, the beginning of each clause should line up with the beginning of other clauses. The beginning, how do you spell beginning? Double N. The beginning of each clause should line up with the beginning of all the clauses.
Sorry, Godwin.
And I think we see, pardon?
Sorry, I was just about to ask, what do you mean by a clause? Or is it something we still need to run?
Come again?
What do you mean by a clause?
A clause.
Yeah, each
A
clause.
statement. A clause, so a clause is, assuming I make the statement that like, what's your name?
Kemi.
Okay, so if I say Kemi is a girl, that's a statement, right? That's a clause. Adetokumbo is a boy. Another one, right? They should line up. One statement should line up exactly, and that the other one. Is that making sense?
Yes, it does. Thank you.
Yeah. Now, if a clause has several parts, they should all appear on separate lines and be indented under the start of the clause to show the relationship. Now, I think most people who do programming would know about this. So if you've done any form of programming at all before, even as on this internship, if you've been to any QA class, any QA lecture, you would see that there's indentation in the way codes are written. So it's the same thing here. So if a clause has several parts, all the parts should appear a separate line and indented under the starts of the main clause to show the relationship. Right. So these are the basic rules, rules for SQL. These cut across all SQL statements. So let's now look at data manipulation. We have said that these are the data manipulation words, right? These ones here. The reserved words are the DML keywords. Now, the first one is select. I just want to give a bit of meaning to that. Select. What does it do? Now, this is used to query the database. Used to query the database. Insert. What does it do? As the name implies, used to insert data into a table. Update. See, my typing is very bad. Used to update data. And then delete finally is used to delete what is not needed. So you would see that databases are made up of tables. We've been talking about table. So they are made up of mainly of tables which have got relationships. It is these relationships that we work on with these words that we have. Right. Let's make some progress. What is the format of a simple database query? I will not say simple, I will just say database query or SQL query. What is the format? It starts, first of all, with the reserved word select. Select. What do you want to select? So when you have made the select statement, or when you have written the select word, what it is that you want to select follows next. Do you want to select a specific thing, or you want to select everything? So you must make a choice of what it is that you want to select. Right? Now, where are you making your selection from? You need to name the table that you are making your selection from. So table name. Now this table name, sometimes you can give it an alias. So when I say an alias, I mean you can give it, for example, if Bidemi's nickname, like a nickname, an alias is like a nickname. In SQL, we work a lot with aliases. Then the next keyword used in SQL here is where. Where. Now, the where reserved word is followed by a condition. It's followed by a condition. Having written up to this stage, the next, if you are continuing, is group by. Now, this is followed by a column list. And it still continues. Having is the next keyword or reserved word here. This is also followed by a condition, but this condition is usually based on aggregate functions. And then finally, you have what is called order by. Order by. And this is a column list. It's followed by a column list. Right. So like I just explained, select specifies what it is that you want to show, what you want to appear. It is what you expect your output to be. Right, so that is select. What you intend your output to be. Now, from specifies the table that you want your outputs from, or the tables that are to be used, the table or tables that are to be used, or that you are selecting from. Right? Now, the where filters the row, where would filter the rows based on some condition that you would specify. We shall come to that. Then the next, group by, forms groups of rows with the same common column value. We shall also experiment that, and then you would see how it works. Having, like I said earlier on, is also filtering based on some condition, usually aggregate functions. I'm not sure if we know what aggregate functions are, but these are things like count, sum, average, minimum, maximum, things like that. Now, order by also specifies an order of output. Right. Now, these are the command statements in the SQL language. All of these, and they follow this order here. This order here cannot be changed. So you can't have from, then select. No, the select has to come first, followed by from, then where, group by, having, order by. It must follow this order. I hope that is very, very clear. It must follow this order. However, not all of these may be used at any particular time. Not all of these need to be used. You only use them based on what you are looking for, or what you intend your output to be. The only exception to that are the first two. These are mandatory. You cannot do without the first two. Select and from. You can't do without them. They are mandatory. They need to always, all the time, anytime come. Is that very, very clear? Right. So the others would be used based on what we are looking for, based on what we are required to retrieve. So let's see some examples. Let's see some examples of how we use this in real life. Let's see. I think now let me go over to my, let me log into my database management studio, and then we can practicalize some of these things. I have it already opened here. Can you see? Can you see my screen?
Yes.
Okay. Let me get out of it and then go back into it. So this is it here. I have it downloaded already. SQL Server Management Studio, SQL Server Management. Right, so let's see what we have. This is our database. It has tables in there. This is where the tables are. These are tables here. All these are tables. Table. All these ones will be DBO, database objects, database object, database objects. So all these are tables. This is another one. All these are tables. Tables. Right. If we want to work on any database, it is important for us to know what is in the tables. To have an idea, not necessarily know, but to have an idea of what is in the tables. So how do we, assuming you've just been employed in an organization, assuming you've just been employed by Facebook to be their chief data analyst, how would you know what they have in their tables? How would you know what they have in their database? Right. What we can do, you see, when I believe we all know how to use Excel spreadsheets. So Excel, not most database tables are made up of, they're just like Excel spreadsheets. They're made up of columns and rows. Right. The columns detect what kind of data we have in the database, whilst the rows form the various data subjects that we have. But the columns form the kind of data that we have. So for example, if you have a table of employees, for example, you would know that you would have maybe employee ID, you would have employee name, first name, surname, maybe their date of birth, maybe the time they started work, or the time they gained employment, how many years they've worked. You might have all of those things in your Excel data, Excel spreadsheet. It's the same thing in a database tables. However, the advantage database tables have is that they form They are made to form relationships. And so we can combine and tweak and twist various tables to derive results from multiple tables at once. Right. But so we need to have an idea of what kind of data we have in each table. Now, it's not always easy when you start to know what kind of data you have in a table, or you might not know the data columns. But how do you get that? How do you get to know that? There are a number of ways, or let me say there are two main ways. You can either ask somebody who's already worked on it, and then they can tell you, or you can experiment yourself. Now, I did mention earlier on that there are two main reserved words that we must use all the time, and these are select and from. So let's see how we can put that in operation here. So I'm going to take one of these tables. I think I'll take the first one. This is the main. So let me change the table into that. So this is the HR employee table. This is an employee table. It's formed by HR, human resources. Right.
Sorry, Godwin.
Yeah.
The SQL HR, is it hidden under another tab? Because I can't seem to find it.
Come again?
The SQL HR that is showing on the left, how did you bring that up, please? Is it hidden under another? Sorry.
Right. So these are tables that I've had formed. When you first of all download the SQL Server, there's nothing in it. You need to input. You need to load it up with data.
No, have you shared the data with us?
No, I haven't.
Okay.
I haven't. I don't know what kind of data you have, but like I did say, these things, it doesn't matter what kind of data you guys have. I'm aware you guys have some data. It doesn't matter what kind of data you have. The format is the same. What to do, the steps to follow are the same. So whatever we learn here, you can easily apply to the table, what you have in your database. Do you get what I'm saying?
Yeah.
Yeah. So we've selected the table that we want to work on. That is what we have selected here. Right. So I can do one of two things. I can say select. If I know my column headers, I can name each and every column header. Or let me do this properly so that I can send it to you properly. Let me number it as I go along. Query 1. Query 1. To retrieve all. I don't know why I keep writing in uppercase. Retrieve all columns. All columns and rows. To retrieve all columns and rows. How do we go about that? I've said you might want to know. So you can, one way is if you already know what the column headers are, that is easy. So what you do is select, and then you just name the column headers. Remember, we said when you use select, it's either you want to specify exactly what you want, or you want to specify everything in your column headers. So you can either choose what you want or you specify everything. That's one way. For the first instance, let's just specify everything. So select, let's say, person ID. Person ID. Employee number. Employee number. Employee number, start dates. When did they start? You know what? I'll just take a few of these. I wouldn't do all of them. Start dates. Start dates. Let me just take these. From. Where are we taking this from? We are taking, like I mentioned earlier on, we're taking this from the employee table, right? So we name the table employees. From employees. And now once your syntax is correct, you see that all the red marks have gone, right? Now, if I were to run this now, if I execute this, you would see that it will produce a result here. Now, if I were to go on, end date, title, forename, surname, birth date or date of birth. So this is one thing. This is one thing I forgot to mention earlier on. There's something called literals. So birth dates, if you happen to write birth date as date of birth, it would not recognize it. In SQL, the words have to be written exactly the way they are entered in the database. So if, for example, you have birth date and then you rather go and write date of birth, you wouldn't have a result for that. So birth dates, gender, address ID, dates item, date time added, date time modified, Right. If I run this now, I'll get something else. I need you, please look at this number here. Down here, 136. That means we have 136 rows of data. 136 rows of data. That is what we have. So we've been, with just this statement, 2 lines of statement, we've been able to produce 136 rows of data. It wouldn't matter at all if there were 1 million rows of data. We would have generated 1 million rows of data. If there were 1 billion rows, we would have generated 1 billion rows of data with just these 2 statements, right? However, you have gone into an organization, you don't know what these things are in the database. How do you go around this? You don't know if the database has got person ID, employee number. Look at this one, for example. If it's birth date or date of birth, you don't know. So what do you do? Let me make this one query 1A. Let me make this 1A. 1A. One B. Instead of writing all of this, there is a shortcut that we can use. Does anybody know that? If you know it, just unmute and tell us. Right, now this one is using the asterisk. Using the asterisk. We all know what the asterisk is, don't we? Or the star. So instead of wasting time writing all of this, see how much time we wasted writing all of this. Instead of that, we can simply say, select star from employees. And let's see whether this would run. Okay, let me take this out so that it doesn't. Let me take this out. So this is not going to run now. This first part for 1A is not going to run because I have commented it out, right? If I run this now, in fact, there will be no change actually. Oh, let's do something. Let's do something else. Let's do something before we do that so that you see that, yes, it works the same way. Oops. Let us take some of these off, right? You've already seen what the result is. So let's take some off. And let's run it. Let me comment this out. So this is not going to run. And let's run this. Okay. No, there is an error here. There is an error here. You see that this has shortened. What we took out now doesn't show, right? It's not showing what we took out. Now let's go and comment this out and run the next statement. So if I run this now, let's see what happens. We get everything back. We get everything that we took out. We took out date time modified, date time added. And I think we took out, no, we didn't take out address ID. We took out these two things. See that we've added them, they've come back. So select star is the same as specifying every column header. Every column header shows. You see person ID, employee, and in fact, it shows in the exact same, it follows the exact same pattern. So employee ID, employee number, start date, end date, title, 4 names, the same way, no difference, right? Okay, what is the downside though of this? What is the downside of this way of querying a database? You have gone into an organization. You do not know what kind of data they have. You go and run a select star statement. a few things could happen. You could either crash the organization's computing system, or you might be lucky and get your results without any consequence. But if you are employed by an organization like Facebook, Google, Twitter, now these organizations are huge with millions, billions of followers. I'm not sure if anybody knows how many users that Facebook has, but I wouldn't be surprised if we have half of the population or more than half of the population of the world on Facebook. I wouldn't be surprised at all. So if you are employed, for example, by Facebook, and then they ask you to run a query, and because you do not know what is in the database, you go and run a select star statement. What you are likely to do is to crash the organization's computing system, because you would produce so much data that if there isn't space, the computing system will not be able to cope. Is that making sense? So what is the way around this? You've gone into an organization for the first time, and you've been asked to run a query. So what you need to do, what I want you to understand is, you want to have an idea of what it is that is in the database. You want to have an idea so as to enable you plan for future use. So that is what we are aiming to do now. Restricting. The number, we need to restrict the number of roles produced or selected. I don't say selected, produced. Restricting the number of roles produced. So how do we do that? Easy. You select all the same, but now, like I said, you just want to have an idea of what is here, right? You just want to have an idea. So you don't need all the 136 rows to have an idea of what is in the database. You don't need all the 1 billion rows to have an idea of what is in the database. You can just have the first row, because the first row depicts whatever is in the whole of the database. But so as not to think, oh, it's just one row that you had, increase it a bit. Say you want the top, you want to have the top 7 or top 10 or top 5. Somebody give me a number.
Top 10.
Top 10. You want to have the top 10. Again, use your star. The star is telling the system to select everything in every column. Everything in every column header is asking it to select. So again, from employees. Employees. Right? So this is what we have. You want to select the top 10. Everything. So 10 is 10 rows, right? And the star is all the column headers. You want every column. The first 10 rows and all the column. You can have a look, have a snapshot. You see that it starts from 1, 2, 3, 4, 34, 4, 5, 6, 7, 8, 9. So you see that it ends here, right? You see 1009. If we run this now, let me comment these out so that it doesn't affect. If we run this now, you will see what we will get. We have the top 10. That's what we have. We have just the top 10, 1 to 10. Any questions at this stage? Any questions? No questions? Are we all good? Can we go on? Right, so now let's go to query 2, the second type of query. In query 2, we want to select specific columns. I think we've done query 2 already. Actually, the first time we tried it. Yeah, I think we've done, but let's just follow this. To retrieve specific columns. Can anybody tell us how we can do that? Like I said, we've actually done this already. Okay, nobody's talking. Let me just take a few. So we want to retrieve specific columns. We don't want everything. We don't want all these columns. We don't want the star. So we just want a few things. Assuming your manager tells you, can you give me the names and the ID and employee numbers of all employees in the organization? I don't want their names. I only want their employee number and then their personal ID. So what do? We just select these. Where do we want it from? From employees. There is an error somewhere. Select, okay. Right, let me comment these out so that we see what happens there. If we run this, so we only want the person ID, we want the person ID, and then we want the employee number. We don't want any other thing. Okay, let me add forename and surname. Forename and surname. Forename and surname. This is what we want. So if we run this, what do we have? That's what we have. And you see, we still have 136 rows. So it has gone round, selected every row, but restricted the columns to just what we have asked it to. So you see, it's manipulating the data. That's why this selects keyword is a data manipulation word. It is to manipulate the data. Right. Let's go to the third type of query that we want to see. Before we go to the third one, I want to do something. I want to go change my database so that it can make better sense to, let me change this to that. Comment this out. Of course, these are all going to be wrong now because I've changed it. These lines don't mean anything. It's simply because I've changed the source of the data. But let me comment it out so that it doesn't confuse anybody. So query 3. For us to, I want us to use another keyword here, but for us to do that, let's experiment with something first. So if we go into the training table, we see that no. It's embedded somewhere. I can't see it, but let's get on. Right. So I just want to use the trading table and a trading table that is embedded in there. So select all. I want to select everything from training. If I run this query, let's see what happens. Train. Did I get the spelling wrong? Training. Select all from training. Train. Train. No. Where is this thing? Train. Grab. I think I've lost the trading table. I don't know how that happened. Let me see if it's down here. I think I've lost the trading table. Oh, okay, it's here. It's here instead. Okay, it's under HR. It's under HR. So let me change my source back to HR. Let me change my source back to HR. Right, so if I run this now, this is what I get. Right, this is what I get. Now look at something. Look at course ID for you. See training ID 1, 2, 3, 4. It follows a particular, no problem with that. But look at course ID 1, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1. And then we go all the way, and then we have 2, 2, 2, 2, 2, 2, 2, 2. Then we have 3, 3, 3, 2, 2, 2, like that. I mean, that can be if you have a million rows of data. and you are having this really, as a data analyst, this doesn't give you any information whatsoever. It doesn't give you any information. So how do you know exactly how many courses that are being offered? How do you know exactly how many products that a business is selling? How do you know exactly how many trainings have been done? Now, so you see this, for example, here introduces a lot of redundancy, repetitions, redundancy. We don't need that. We don't need that. The way to go around this is to use the keyword distinct. Query 3b. Let me put this 3a. Use of distinct. Use of the word distinct. Right, let's see how that works first. Let's just select, if we just take this course ID, let's just look at the course ID. If we run this one, this is what I was talking about. You see the repetitions that we have here. We don't need that. We don't need all of this. It's redundant data. So to get rid of this, we use the keyword distinct. Distinct course ID. We use the keyword distinct and let's see what happens. Do we see what happened? Can we see what has happened? All of a sudden, we know that we have 7 courses offered. We have 7 courses, not that we have course ID 1, 2, 3, 4, 5, 6, 7. Forget about the numbers here. But these are the course IDs that we have. Right, so it doesn't matter how many people are on course ID 1. We just want to know the number of courses that we have. We want to see that we have these courses, 7 courses. Yeah, these are all the courses that are on offer. It doesn't matter how many people are on each course. We don't need that information. Right, so that's where the word distinct. So the word distinct is used in removing redundancy. Where there is repeated data, you use the word distinct to remove, let me put that here. To remove redundancy. Redundancy. Right. Now let's go to the next type of query. Here we want to find calculated fields. Calculated fields, calculated values. Assuming we want to find calculations. We want to do calculations with our SQL now. Performing calculations. But before we do that, let's just have a look at what we have. Where do we have? Okay, I want to use the same. On what can we perform calculations? If you look here, can we perform calculation on any of these? Can we perform calculations on address, courses, dates? Yeah, we can perform calculations on dates, but we haven't gotten to dates at all yet. Date is a very, very big thing in data analysis, in SQL especially. Security, employee security, no. Work, employee, work hours, employee history, jobs, training, marital status. We can't perform calculation on any of these. The only element here we can perform calculation on is employee pay. So let's look at what we can do with that. Now let's see from employee pay. Let's see what we have from employee pay. Elements. Let's run this query and see what that would give us. That gives us some values, right? We see that some people are paid. These are the pay values. Some people are on salary. Some people are on hourly pay. Can we perform calculations with this? Yes, we can. Some are on salaried work. So yeah, we can perform calculations on all of these. That's what we want to look at now. Right, so how can we perform calculation? Let's see what we can do. Let me copy this. So this is 4A, 4A, 4A. 4B. Right, so we select. Now we know some of the things here. So let's see if we can modify this statement a bit. Instead of selecting everything, let's select a few things. So select, let's say, pay element ID. We want the pay element ID so that we can know what is linked to what. Select pay element ID. Pay element ID. And select person ID. So what pay is linked to who? Person ID. What is their pay value? How much are they paid? Pay value. Right. But we want to do something. We want to do something. If we were just to run this, if we were just to run this thing here, there is an error somewhere. Okay, cool. If we run this one, we would get, this is what we would have. We want the pay elements, a pay element ID, the person ID, and then the pay value. But this just gives us, it doesn't really tell us much, does it? It doesn't tell us much. But if we were, for example, to say, let's calculate the monthly salary for just the salaried workers. If we were to calculate just the salaried workers, then what do we do? How do we get the salary? This obviously is yearly pay, right? So if we were to say pay value, this per year, so a month will be, there are 12 months in a year. What do? We can divide this pay value by 12 and it would work perfectly fine. Pay value divided by 12. I believe we all know that this is divide sign. If we run this statement, this is what we have. Unfortunately, because we haven't restricted the rows to just calculate the salaries, it has divided everything by 12, resulting in us having this. That's not a problem at all. I just want to use this as we will come to the point where we will be able to restrict the rows in our queries. Right. So where you see we've done pay value divided by 12, and then a new column has been created for that column. A new column here is created for that header. But we can actually name this. We can give it a name. We can give it a name, and that becomes, should I do it? Okay, let me do it separately. Do it separately so that when you are as monthly salary, monthly salary. If I run this now, it gives me, you'll see that the column name here, the column header would change. And let's see what it becomes. Instead of the nothing up here, we have monthly salary here. So this is one way by which we can assign column names to the various column headers. So when you have created a user-defined variable, you can actually name it, give it a name of your choice, as we mentioned earlier on. Right. We will come back to this when we do the where clause. We will come back to this. Like I said, we don't want to see all of these things here because it doesn't give a good reflection. You can see somebody's monthly salary is this 0.8709. It doesn't reflect well in our query. We only want those on monthly salary. We don't want those on hourly wages. So we would come back to this statement when we do the where clause. The where clause is what we use in selecting rows. Right. So that takes us to query 5. So we haven't finished this. We'll come back to query 4. Or we would integrate it with query 5. And query 5 is quite long. It's quite a long. This one is quite a big one. So when do we use the where clause? We use the where clause when we want to restrict rows. Let me just put all of this in one. We use the where clause when we want to restrict rows. Okay, it's followed by a search condition. Yes. Does a child want to join us? Allow them, please. Now, there are 5 basic search conditions. Please, this is very, very, very important. This part is crucial. There are 5 basic. Five basic search conditions. So I'm going to name them 5.1 up to 5.5. 5.1. Now you would notice that I'm using this. I believe most of you know this here. This sign here is served the same purpose as this one, to comment out. But this, I'm using this because I'm going to write, I'll be writing, and this is just for one line at a time. These ones here. But this is for multiple lines at a time. So 5.1, we have what we call the comparison condition. Comparison. Condition. Now this is where the value of one expression is compared to another. Compared. Another. Where the value of one expression is compared to another. .2. we have the range condition. Range. Now, this tests whether a value of an expression falls within a specified range. Five point 3. We will take these one by one. Sets membership. Now, this tests whether the value of an expression is equal to one of the set values. So you have a set value. Whether the value of a particular expression is equal to anything within that set. So test whether the value of an expression is equal to one of the set values. So if it's equal to one of the set values, then it's a member of that set. That is basically what it means. Then we have pattern match. Match, M-A-T-C-H. Now this tests whether a string matches a specified pattern. Sorry, I have some dogs here. Whether a string matches a specified pattern. And the last where condition 5.5. Now this is the null. And this is very important. The null is a big thing in SQL. Tests whether a column has a null. Before we go on with that, before we go back to 5.1, can anybody tell me what a null means? Can anybody tell me what a null means? Please. I need help.
Does it mean zero?
Zero invalid.
Pardon?
Zero invalid.
Zero or invalid.
Data doesn't exist.
Data doesn't exist in the
Pardon?
database.
Pardon?
Value doesn't exist in database.
Are you sure? Any other one?
Empty.
Empty. I doubt.
If it's something that has no value.
I doubt. I doubt. Yeah, you're all close, but not really, not exact. Now, the null simply means the value is unknown. So it is not 0. It is not that it has no value. It is not that it doesn't exist. It is simply that we don't know what it is. So that is what makes the null very, very tricky. And so to use the null has got special, there are ways around using the null. So the value of the null is simply a value that is not known. Okay, so let's see how we can make use of these.
Okay, can you check 5.3? That's whether the spelling, the type.
Where is that?
5.3.
Test whether, oh, okay, thank you. Right, so now let me close this. Let me close this. So these are the things we are going to talk about in query 5, yeah? These are the things we're going to talk about. So the first is comparison search condition. Comparison. How are there any mathematicians in this house? Any mathematicians here? How many of us know the comparison operators? Comparison operators. Okay, let me put this under that. Now let me do it separately. Let me do it separately. Comparison operators. Comparison operators. Operators. Yeah, do we know the comparison operators? Okay, I'll give you the first one. Equal to. Who knows the next one? Who knows the next one? Less than.
Greater than, yeah.
Greater than. Less than or equal to. Oops. Less than or equal to. Greater than or equal to. And who knows what this is? Does anybody know what that is? Does anybody know what that is?
Range.
Don't be deceived. Don't be deceived because it looks like that. It's not. Actually, this and that are the same thing. And who knows what this is? Who knows what the last one is? Not equal to. So this is equal to, this one is not equal to. This is not equal. So here simply what it says is that it is greater than, is less than or equal to, and at the same time greater than or equal to. Is less than at the same time greater than. How can that be? So it's not equal to. It can't be less than and at the same time greater than. So I cannot say that 2 is less than 3 and at the same time greater than 3. It's not possible. So this and that are actually the same. This is also not equal to. So you can either write this or you can write that. It doesn't matter at all what you write. Right. So now so I've closed these ones. So let's go on to Let's go on to carry out some tests. So let's go to 5.1. Let's go back to 5.1. Assuming we're working with pay elements, right? So assuming we want to select from pay elements, let me just go back there and copy pay elements. Select from pay elements. Instead of writing it down, select. Okay, let me just write it. Select all. Select everything from pay elements. From pay elements. We now want to put a condition there where the pay value, let's take any one of these conditions, any one of these comparison operators, where the pay value is, for example, greater than 30,000. Where the pay value is greater than 30,000. And let's run it and see what result we will get. All these things are okay. Let me comment this out. Everything commented out. So let me run this. Let's run this and see what we would get. If you look at this, the result here, you would see that the result, it has given us a result where all the pay values, the value we have here, there's none that is either 30,000 or less. Each and every one of this is greater than 30,000. Each and every one. So that's the power of SQL. You can use it to produce. Oh yeah, there's one thing too that I forgot to mention. It doesn't matter from the beginning. SQL is not a procedural language. It's not procedural. It doesn't follow any it doesn't follow a procedure. Most most computing languages follow certain procedures. SQL is not, it's a non-procedural language, and what that simply means is that it only gives us the result of what we want. We don't need to specify how to get that result. So if we were writing this in some other language, we would have had to specify how to get these results here. But SQL, we just write what we want. We just want where the pay value is greater than 30,000, and it gives us all the pay values that are greater than 30,000. Right? Now let's go to another. Let's take another one. We can also see if it's less than. Let's see less than 30,000 and see what we get from that. I'm sure that one will give us some of the hourly paid things. If we were to do less than, yep, that would give us that. So if we run this, this is what we have. And like I said, you see that it's giving us values which are less than 30,000. All the values less than 30,000 we have. All the values less than 30,000. So we know how to use the comparison operators here. We know how to use the comparison operators. But let's see, we can compound these operators. Instead of using just one, let's use a multiple of them. Let's use two. So that's 5.1.2. 5.1.2. Let's see how we can work that out. Select all from pay elements where pay value is less than 30,000. Pay value is less than 30,000 or end date. We are now making it a little bit complex, right? End date or end date is we know what this sign means, right? This operator means. Do we remember what this means?
Not equal to.
Pardon? Not equal to. Thank you. It's not null. Right. So let's run this and see what we get. So you see here, end dates, most of you have null in all of them. We don't want the end dates where the end date is null. We don't want them. Where end dates, we want these values here, but we don't want those ones that end date is null. Right? Where end date is not null. We don't want those ones. So let's comment these out. And then let's run this and see what we get. Mm-hmm. 30,000, less than 30,000, or end date is null. Do we know why we have end date is null? Why we have null in this? What would happen if we were to change this to and? If we were to change the or to and? What would happen if we did that? We execute this. Let's see what we get. It doesn't give us anything, does it? Simply because there is nothing like that. There is no instance where the pay value is less than 30,000 and end date is not null. That is why this doesn't give us anything. Let's look at another one. I'm not sure if we know how the and or work. Let's take this out. So pay value where this is that, or end date is equal to that. Let's run that and see. Then we shall also run it with the AND in that same way and see what we get. So this is saying pay value is less than 30,000 or end date is equal to null. So we want here, we want the end date being equal to null. Now let's use AND instead of this and see what it will result. Let's comparing it with what we have here. Again, it doesn't give us anything because there is nothing in the database where 30,000 and end date is equal to null. Let's use another comparison search to see if that would produce anything. Okay, let me use job ID. We saw job ID earlier on. Job ID. Job ID is greater than 6. Let's see what that gives us. Where the salary pay value is less than 30,000 or job ID is greater than 6. Is this making sense at all? I'm seeing 4 here. Why do we have 4, 5, 4? Can anybody tell us why? We are saying job ID should be greater than 6.
Because we also have this condition of pay value greater than 30,000.
Okay, so yeah, I just wanted to because I couldn't get anything with the AND. I just want to see what we will get with these ones. I'm sure this will definitely give us something with the AND. So it's either this or that. Either this or that. So either it's less than 30,000 or it is bigger than 6. So even when it is 30,000, but if it's less than 30,000 and the job ID is less than 6, it will still show up because the pay value here is less than 30,000. The job ID here is 4. It has still shown because of this or clause here, the or function here. Right, let's use and see what we will get with that. So here we see that we say the pay value should be less than 30,000, and at the same time, the job ID should be greater than 6. So these two conditions must be met, not just one of them, unlike unlike here. So with this one, if one of them is met, the value would be shown. But here, both conditions need to be met for the value to show. So you see that in this instance, there is no job ID that is less than 6. There is no job ID that is less than 6. They are all greater than 6, right? And also, all the pay values are less than 30,000. There's no pay value that is greater than 30,000. Right, so let's go to the next condition. Are we still here? We are meant to finish at 11. Can we still continue?
Yes.
You still want us to continue?
Yes, please.
So this is the range condition. That's the second one we spoke about, the range. Where is it? 5.2 range. From the top of your head, can you think of a word that would form that we can use here? Range. Can anybody think of a word that we can use? I'm going to write it down now. Can anybody think? Can anybody help me? It starts with B, followed by E, then T. Between. And not between. So you want to compare things. It's between a range, right? The word between. That is what it's, you see, SQL is quite easy to use, isn't it? It's just English, manipulating the English word. So let's see. Again, let's use the same things. So we want to select all from pay elements where the pay value is between two figures. Where the pay value is between two figures. So pay value between, the between word should come now. Between what and what? Let's see, we've used 30,000 for quite some time. So let's use 40,000. And what else? 40,000 and let's say 70,000. And let's see what that would give us. Does that give us anything?
Yes, it does.
I think it does. Yes, it's given us these values here. So we have three people who earn between 40 and 70. Obviously, nobody earns above 55. That is why nobody earns between above 55 and 70. That is why we don't have anything over 55,000. But if we were to have something over 55, but less than 70, it would have come up, right? So this is how we use the between statement. And we can also say not between. So that would give us values which are not between this range. Not between. All we need to do is to put something here, and then we can run this. And that's us done. Not between. So you see all the rest have come up now. Oh, we have so many. All the rest have come up. Yeah. Not between. let's say that not between and one, two. Let's do the third one. Set membership. For us to do that, let's go back to set membership. Set membership. Let's go. What can I use for that? Set membership. Let me see. Let me go back to the original. Select all from pay elements. Select all from pay elements. Let me run this again and see what I can. Let me choose something to use from here. Select all from pay elements. Okay, that's not giving me anything that I want to use here. Let me see if I can get something. Marital status. You must be a member of something. This we can't have membership in anything here. We can have membership in anything here. So let's choose something that we can have membership from. Yeah, I think I know what it is. We can have membership in marital status. It's either somebody is married or not married, or let's run that query and see. Let's run that query and see. Query 5.3. Query 5.3. Sets membership. Set membership, search condition. And the words we use for set membership is either somebody is a member or not a member. So the person must be either in that membership or not in the membership. You are either in or not in. In or not in. That's this membership condition. So let's see. Let's select all so that we see what we can get from this table here. Marital status. Select all from marital status. Did I close this? Did I close that? Did I close that? Yep, I did. Okay, so let me run this. All right, so these are married, these are separated, these are divorced, these are cohabiting, these are singles. Right, so we can work with this. Some people can belong to, so it's like belonging to a particular kind of group or category. Right. So if we were to do this again, 5.3, we were to do this again, where marital status where marital status in married. Something is going to happen here. I don't know if anybody can see what has happened. We want to find out those people who are married, but why is this underlined red? It means an error. Who can tell us why?
There's no column with that title, that heading.
There's no what?
There's no field or column with that married title.
Oh, there is. There is married.
You didn't close it.
There is married. There is married. See married?
You didn't close it.
Didn't I? I did. Didn't close what?
After the marriage, there should be like a call
Yeah, but there was no column here. There was nothing here. There was nothing. I could have put it there, but there was nothing in all of these I didn't put. So that shouldn't be the case. That shouldn't be the reason. Right. So it is because we've chosen a value from here into our query. Now, what type of data is this? This type of data is a string, so it has to be in quotes. It has to be in quotes. Now it has changed. The red line has gone, but this has become, now this simply means that it's a value we have taken from in here. And if I were to write it in lowercase, it will still be the same. Right? So if we run this, let's see what we would get. I believe we all know what a string is. You know the data, we know that we have data types, right? So this is a string from in here. That is why this has to, that's why I put it in quotation marks and then in the brackets. So if we run it, this is what we have. These are the married people in there. All these belong to the same set. They belong to the same group. They all belong to the same group. So we can also do not married. And then we would have that. Not in married. So we just put not here. And then if we comment these out, it should give us all the other ones that are not married. So we have the separated, we have the divorced, we have those cohabiting, but they are not married. We have the singles, we have the separate singles, all the rest are here except the married. There is no married person in this, in the rest, there is no married person. So let's also make this, let's compound this a bit. Let's compound this a bit. Like we did with the comparison statement. Let's compound this a bit and see what the outcome would be. So we could have them being married and at the same time cohabiting. Cohabiting. Written anywhere here, cohabit. Cohabiting. Let me put it in quotes. Right. So if I run this now, so we have married and cohabiting. We have people like that. Now, with this done, I want us to look at back to between. This is something that, no, I'll leave that till another day. I'll leave that to another day. Otherwise, it will take time. Then the next one is also a big one. 5.4, pattern match. Pattern match search condition. So can anyone think of a word that would give us a pattern that would make something? Oh yeah, yeah. If I say it, I'll give it away. That would make something look what word am I looking for? Like. So pattern match. Does this pattern look like that? Look like, right? Look like. Now to get this, to use this pattern match condition, we come to what is called wildcards. Wildcards. You can't just, if you say, because you want something to look at something, you are not really sure what you want, right? So that uncertainty means you must use a wildcard, which will produce something that matches what you are looking for. It may not be exact, but it matches it. And that is why we use the wildcard. That's why we use the wildcard. Now, there are various instances of wildcard. What are the instances? Yep, the first is the percentage sign. It's a wildcard. The percentage sign is a wildcard. The next wildcard is, if I do this, it will look like the same thing. Okay, the next is the underscore. I hope you're able to differentiate though. Can you differentiate that from that? The next wildcard is the underscore. These are the two wildcards that we want to look at, but there are different ways that these are used. There are different ways by which we can use these wildcards. So we'll look at each one in turn. One moment. Let me look at my notes. Yep, so let's do 4.5.41. 5.4.1. If we have something like H, wildcard, that, what does this mean? Now, what this means is that the first letter must be H. Can everybody see the H here? I can't make my screen bigger, but I hope you can see it. What this simply means is that the first letter here must necessarily, the first letter of whatever it is that you are looking for, must necessarily be H. The rest can be anything. The rest can be anything. That's 5.4.1. 5.4.2. 5.4.2. If we have this, Now I want somebody to tell me what this means. What does this mean?
It means the last letter must be K, right?
Beautiful. It means anything that comes before K. We don't care about anything that comes before K. The last letter must necessarily be K. Last letter must be K. That is what it means. The rest can be anything. So 5.4.3. Sorry. What does this mean? Can we see the word between the percentage signs?
Yes.
Can anybody see?
You're looking for the exact words.
No, we are not looking for the exact word. Now it
The
means
letter between
that,
must be Glasgow.
pardon?
The one between must be Glasgow.
No, it means that from what we are looking for, Glasgow must be in there. It doesn't matter what it is that we are looking for. Anything that it is that we are looking for, Glasgow must be part of that thing. Right? Glasgow must be part of that. Glasgow must be part of whatever we are looking for. Now, 5.4.4. Can we still continue? Please let me know if you are tired. I'm sure if Digi was here, you say, God, let's continue next time.
My battery is about low.
But your battery is low.
Let's continue next time.
Oh, Oh dear, I didn't know that you was here.
No, you called me. I just entered. I always hear my name from anywhere. Let's yeah. Let's pick it up next time anyway. So it seems so if you can wrap up, that would be good. Thank you.
Okay, sir. So now let's see, not like. Actually, these ones should all have like. This one should all have like. And this one is not like. So if we have this, then Glasgow should not appear, right? Not like. If we have this, Glasgow should not appear. Glasgow must not be part. Must not be part. And also in the same vein, if I were to put not like here, if I put not like, then this part is that H cannot be part, or H cannot be a first character. Is that okay? Right? In the same way, if we have, so we have used the percentage sign. Now let's quickly use the underscore. Let's explain how we can use the underscore. Then we would. Yeah, I think we can finish with the underscore. There's just a little left anyway. The underscore. So if we have something like this, I'm not sure you can know. Okay, what I'm going to do, there shouldn't be space, but I'm going to leave space so that you see it clearly. Yeah. So what does this mean? Now, this simply means that there must be, how many underscores do we have here? 1, 2, 3, 4. There must be exactly 4 other characters after the H. The first character is H, but there must be 4 other characters following the H. In the same way, if we have this, say P, there must be 3 characters before the P. Right. So if we can use this, for example, in, let's say, if we want to find addresses we don't know. I mean, you want to search an address, you don't know exactly where it is. You can use, I think we will need to come back to this. But let me quickly do the last one. We haven't really exhausted this. DJ, I think we should stop, Abby. It's 11:30.
So sure, yeah. So let's just take a pause, not stop anyway. Let's stop and restart next time anyway.
Okay, so
well, it's been really, really fantastic. Thank you so much for that. Yeah. So and maybe 1 or 2 minutes if anyone has got any questions about what we've done today. And who is recording?
Prep Major.
Prep Major. Okay. All right. So maybe because I was thinking that this also could be useful for the QAs as well. So maybe we'll make the video available for them later. Yeah. Okay. All right. Thank you so much, Godwin, for that. It's really, really
thank you, sir.
I'll
post the notes.
Okay.
I'll give the notes to allow me to post to the group.
All right, cool. That's brilliant. Yeah. All right. Thank you, everyone. Yeah.
Thank you, sir.
Thank you so much.
Yes, sir. Thank you.
Thank you. Thank you, sir. Good night.
Good night.
Good night. Mr. God, is it possible to have the data you used?
You mean that means I'll be giving you my whole database.
Oh, okay, that's okay then. Thank you.
Thank you.
Thank you, sir. Have a good evening. Bye.
Good evening. But we can arrange data anyway, so we can.
Yeah. Let's arrange that.
But
Yes.
if we have to do that, then we need to create, and we haven't gotten to create at all yet.
Okay.
Create to be like maybe 6 lessons from now.
Okay. All right. Because they need to have something to play with anyway. So, but what we can do is if of course, I don't think this is sensitive data. You can create a DOM, right? And I think they know how to kind of import anyway, because they've been taught in the other class anyway.
Okay.
How to import, yeah. So if you export this data database, and they can import into their own SQL management studio anyway. So
okay, sir.
Yeah. Okay. So we can go through that in the next class if that's okay. Or it will be good for them to have a playground to play.
All right, sir.
Okay. All right. Thank you. Yeah. Cheers.
Thank you, sir.
Thank you, sir. Thank you, everyone. Bye.